Hello, everyone. My name is Donald Clark, and I'm an engineering manager within the Cash Cloud Platform organization within Cash App. Our organization serves the product teams by building tools and services that enable them to build products quickly and safely. I lead the traffic and observability teams at Cash. The traffic team is responsible for the service mesh operating on the Cash Cloud platform, while the observability team is responsible for tools that are critical for monitoring and supporting incident responses. It is through this observability lens that I view our incident response and postmortem practices. My colleague, Ryan Lowe, who is also an engineering manager at Cash App, was unfortunately unable to present with me today because of an emergency, but I wanted to give him a quick shout out for helping me with this presentation. I'm here today to talk about how we at Cash App strive to run pedagogical postmortems. I'm pretty sure that we are all familiar with blameless postmortems, taking holistic views, and having a constructive mindset. The purpose of this talk is to show how we have taken all of those amazing resources and philosophies and turned them into our own process that we have had success with. I will start today's presentation by telling a fictional story of an incident that we think is a great example of our processes, give a summary background of Cash App, and then do a deeper dive into our incident response process with a specific emphasis on our postmortems. With that, it's story time. Imagine a scenario where something happens that causes a critical service to go dark for about 10 minutes. Now imagine you handle everything perfectly in those 10 minutes while the critical service is dark. The correct people were paged, got online, investigated the incident, and fixed the root cause. Congratulations. This should theoretically have been the end of the incident, with a few million requests having failed, and then the service began working correctly and everybody moving on with their lives. Okay, but now imagine something else. Unbeknownst to those on-call engineers, those few million failed requests were in the critical path. So there were protections put in place to aggressively retry to ensure that the customer experience was a good one. As a result, once the service was restored, the second outage began. Those few million requests over 10 minutes turned into billions of requests due to retries. Of course, this thundering herd overwhelms the original service and causes cascading issues throughout the stack for nearly an hour because it was more traffic than the service had ever seen. Even a really well-designed system may be designed to be able to withstand some multiple of current peak traffic levels in case of spikes like this, but imagine that. In this case, the load was hundreds of times of normal peak traffic, overwhelming the system. So what does this fictional company do once the incident was over? As a first step, it makes sense to perform a bunch of root cause analyses and have a postmortem. The postmortem can result in some decision trees formalizing the process by which the company can decide vendor redundancy, but more importantly, it should begin a large discussion about error retries. Within the postmortem, the company can discuss a variety of approaches and hopefully eventually converge on using an exponential backoff, which is to use progressively longer waits between retries for consecutive error messages with a maximum delay interval and a cap on the number of retries. Maybe the company just leaves it there, with the service in question agreeing to implement that approach. But would that be enough? It would have left the company with only a fix for one out of hundreds of services. What if instead the company took a multi-pronged approach? First, what if the company added this functionality into the service container and made it the default option for error retries? Second, what if the company educated engineers about this decision, what its ramifications would be, and what to expect? And third, what if the company published an internal blog post about error rates and exponential backoff? With that kind of approach, it's possible that the company in this story might have effectively eliminated this class of problem. The moral of this story is that companies have had great success thinking holistically about outages and making sure that not only is education a part of the fix, but tooling as well in order to make it more difficult to ever have these classes of problems again. And now we'll transition into introducing some background on our company. Cash App is a product within Square. At Cash App, we are in an interesting position where we aren't a tiny organization, but we aren't a behemoth either. Rather, we are somewhere in between, which is where I expect most of the attendees of the conference are as well. I feel like this slide was much more interesting when I had actual numbers, but I don't think I'm really allowed to share specifics here. We have hundreds of engineers spread across tens of teams managing hundreds of services. These services are spread across the globe over thousands of cloud container instances and result in hundreds of pages per day on average, which leads to tens of postmortems per quarter. Anyway, the point here is that we find our approach to be appropriate for our organizational size right now. The process was different when we were smaller, and surely it will be different when we are larger. We have a core group of volunteer engineers who are always evaluating the process to ensure that we follow the best practices that manifest for our company size and state. Cash App's technology stack is based on a service-oriented architecture that supports both synchronous communication via gRPC and HTTP, as well as asynchronous communication via Kafka. Although our platform runs a variety of applications written in several different programming languages, product teams at Cash App build their services on top of one of two service containers, which are written in Kotlin and Go. Our service containers are designed to remove the majority of the plumbing work required for all applications, such as service-to-service communication, observability, database abstractions, and more. This model allows application owners to focus on writing business logic to power their products. Cash App's infrastructure is built on top of Amazon EKS running on EC2. We use Prometheus for scraping metrics, and we send alerts to PagerDuty, which routes pages to our on-call engineers. At Cash App, we mainly preach, teach, and implement metrics-based alerting. We used to commonly use exceptions-based alerting, but generally found that this does not scale, especially since applications mature and the exceptions become noisy. What this means is we alert on things like whether a metric goes above or below certain values for a period of time, anomalous rates of change, uptime, and more. This slide shows an example Prometheus alert rule that will fire when my job's average request latency exceeds half a second for 10 minutes. Having such a comprehensive approach to alerting allows us to really focus on eliminating false positives and pay attention to the quality of life of on-call engineers. Next, we will discuss Cash App's general incident response process. At a high level, our incident response process can be broken down into four main stages. First is the outage itself. On-call engineers get paged, triage the issue, and assign roles. Those roles include responders, who actively are working on diagnosing and fixing the issue, communications, who communicate the outage to the broader engineering organization, recorders, who, in conjunction with our automated systems, file a SEV and create relevant documentation, which will later be used in the root cause analysis and postmortem processes, and customer specialists, who communicate with customers, deal with status pages, and help determine customer impact if relevant. Next is the mitigation, where on-call engineers explore ways to mitigate the outage as soon as possible. This usually includes things like rolling back a deployment, shedding load, splunking logs, and things like that. Once the outage is resolved, our engineering organization investigates the root cause, after which a postmortem is conducted to review the incident, to discuss the root cause, and determine next steps to ensure that this class of outage doesn't happen again. We first begin by discussing the initial outage. When an outage occurs, one or more on-call engineers are paged, and they are responsible for determining a severity level and filing a SEV using an internal incident response system. This action generates a ticket in an issue tracker system, creates a Slack channel specific to the incident to facilitate communication, and broadcasts the incident to the entire engineering organization in the form of a Slack message and email. While the incident is occurring, on-call engineers post investigations and other relevant information to the aforementioned Slack channel so that a timeline can be created later for the postmortem. Next, we discuss our general strategies for mitigating the incident. Because we've invested significantly in observability tools backed by logs, metrics, traces, and code profiles, our on-call engineers are able to quickly investigate the incident to determine the right course of action towards achieving stability. Obviously, we start with the easiest items. Because we have hundreds of services, many of which are on auto-deploy, we look for any code deployments, configuration changes, or feature flag updates that immediately precede the outage and roll those back, ideally one at a time so we can clearly observe cause and effect. Next, if the issue is clearly load related, we can shed load using circuit breakers, rate limiting, or traffic shifting. As I mentioned before, we build our systems to scale at multiples beyond our peak load. So this is not often an issue, but it is easy enough that we do look at it early in the triage process. If there's nothing to roll back and there doesn't seem to be an issue related to load, we turn to good old debugging of the system. The issue could be related to a bad database query, a backfill running that generates resource contention, a noisy neighbor, and more. A bit of creativity and digging through various telemetry emitted by the system will usually reveal the culprit. Regardless of the mechanism, the goal is to bring our system back to stability. All of these strategies, including the specific actions that were taken, are inscribed into the incident-specific Slack channel. Once the incident is mitigated, the status is communicated out to all of engineering through the incident response system. Upon achieving stability, our goal turns to understanding what happened. Using various telemetry available at our disposal, our team investigates the issue to understand the root cause. It's a grueling process, but more often than not, our engineers are able to trace through and describe exactly what happened in great detail. At this point, we are ready for the final step in the incident response process, which is the postmortem. First and foremost, we begin by discussing why we run postmortems in the first place. A postmortem serves three main purposes. First, we identify systemic issues that would have prevented or mitigated the incident. Second, we hold teams accountable for the reliability of their services and their customer impact. And finally, we provide a review of emergency actions for compliance reasons. The first step in the postmortem process is to schedule it as soon as possible, usually within a week of the incident. Scheduling the incident within a tight time frame has the benefit of ensuring the outage is fresh on people's minds while ensuring that longer-term remediations are discussed and prioritized quickly. At Cash App, we have a system that enables engineers to easily schedule a postmortem, which ultimately turns into a calendar invite for incident leads as well as topical members that were part of the outage. As the Google SRE book states, quote, "A prompt postmortem tends to be more accurate because information is fresh in the contributors' minds. The people who are affected by the outage are waiting for an explanation and some demonstration that you have things under control. The longer you wait, the more they fill the gaps with the products of their imagination, and that seldom works in your favor," unquote. The next step in the postmortem process is for the incident lead to fill out a postmortem document before the meeting occurs. The postmortem document contains the summary, timeline, business impact, response, root cause analysis, remediation steps, and any action items that need to be addressed to close out the incident. A template is available in our internal wiki with a guided prompt to make it easy for the incident lead to fill in the sections. It's worth noting that some of the sections in the postmortem document, such as the action items, are actually filled out during the postmortem meeting. Let's use the fictional story from the beginning of the presentation to fill out an example postmortem doc. The first section of the postmortem doc is the summary, which should contain a 1 to 2 sentence description of the incident. For example, in our fictional story, the summary might be something like, "Aggressive request retry strategy during peak traffic induces a thundering herd that overwhelms service foo and all of its downstream dependencies." This succinctly provides a description of what happened to the audience. The second section of the postmortem document is the timeline section, which should contain a timestamped list of all events and actions that were taken during the incident. The timeline is a great way to take the audience through what happened in the incident and is a good place to retrospectively extract learning lessons for future incidents. Note that because we are a globally distributed team of engineers, we make sure timestamps are in UTC time zone to avoid confusion. The third section of the postmortem document is the business impact. Unfortunately, I'm not at liberty to disclose exactly what goes in that section for Cash App, but you can imagine the types of data one might inscribe. This section will likely be specific to your company based on the type of businesses you run, but the important thing to note here is that we don't conduct postmortems at Cash App unless there is some impact to the business. The fourth section of the postmortem doc is the response section. This is where we collect and document metrics related to the incident response, such as time to recovery and time until first notification. For example, in our fictional story, the time until first notification, meaning when did an engineer receive the first page, might have been 15 minutes from the beginning of the incident. And the time to recovery, meaning the duration of time it took for the incident to be mitigated from start to finish, may have been 36 minutes. The fifth section of the postmortem doc is the root cause analysis. At Cash App, we use the 5 whys technique, which is an iterative, interrogative technique used to explore the cause and effect relationships underlying a particular problem. Some key questions we consider are, was the incident caused by a bug? Why wasn't this caught in testing or in staging? And were there any external factors that exacerbated the issue? The goal here is to uncover processes or lack of processes that are not working well or failing for Cash App. For example, in our fictional story, we may ask questions like, why did Service Foo start to fail requests? And why did Service Foo get overwhelmed from the retry strategy? To progressively inch our way to the root cause. We may not need to come up with exactly 5 whys, but it's a good rule of thumb to uncover all the issues that occurred in an incident. The 6th section of the postmortem doc is the remediation section. In this section, we answer questions like, what was done to stabilize the issue? And will this happen again in the future? The goal here is to capture short-term fixes that we made to stabilize the incident and to describe longer-term fixes, if any, that may need to be addressed. I say may because sometimes the longer-term remediation is too expensive to pursue in the status quo, and therefore doesn't make sense for the business at this time. The final section of the postmortem doc is the action items section. This is where we list both short-term and long-term action items that need to be addressed and prioritized by the owning teams. These action items make its way into our internal issue tracking system with a clear owner to ensure the task is driven to completion. As stated earlier, long-term remediations may not make it into the action item because it is too costly to pursue. Once the postmortem doc is filled out, we finally get to the postmortem meeting. The meeting is led by the incident lead and filled with folks that were a part of the incident, as well as one or more members of an internal committee that monitors all postmortems at Cash App. The incident lead presents the postmortem doc while answering questions that come up. At the conclusion of the meeting, action items are created in a ticket tracking system, and response metrics like time to recovery are tracked in another system so that these metrics can be monitored and compared over time. Perhaps, as the title of this talk implies, the most important aspect of Cash's postmortem process is to ensure the process is blameless. In practice, what this means is that engineers are not allowed to point out who's at fault, and although there is an incident lead, in practice, the incident lead is simply there to present the outage, the meat of the postmortem, and facilitate the action items that need to be taken by various teams that own the issue. The meeting is meant to foster an environment of learning that will improve the organization as a whole, which is why all postmortem write-ups are sent to the entire engineering organization. We haven't mentioned this yet, but our quarterly learnings are a big part of our incident response process. At Square, every quarter, a group of us look for trends and interesting data points in all of the postmortems that were held in the previous quarter, and we write up a document and send it to all of the engineers throughout the organization. The idea, of course, being that it will get read and all engineers will proactively look for opportunities to avoid the problems that we encountered in the past. I will admit, though, that this felt like an effort in futility when we first started. The first time we did it, we wrote up an email, sent it out, and got great feedback. Then, the following quarter, we wrote a new one and found that 3 of the 4 issues we had identified in the first one remained the same. At this point, we just told ourselves that some problems are hard to fix, and they likely just took more than a quarter to roll out. It was when the 3rd quarter rolled around and had the same exact list that we had, where we had to conclude that some things won't get fixed on its own. We fixed this process by augmenting learning with additional items like dashboard reviews, as well as ensuring that tooling was always a component. Certain classes of issues are hard to fix at an individual team level and require an investment by the platform organization to make it easier for individual teams to succeed. The most recent bit of change we're introducing as part of the postmortem process is the dashboard review. A Cash App, simply spinning up a new service will get you service dashboards for free, but every service has at least one, if not a handful, of application-specific metrics that make it unique. Every service gets a status endpoint where we can compare its uptime versus its SLO, but that is only the most basic way. Most API endpoints have SLOs for both availability and latency, and this is the interesting part of the dashboard review. Based on what we learned during postmortem, some services may be called to dashboard review, which is a 30-minute session where we do a deep dive into service observability so that we can ensure that alerts are configured correctly based on their SLOs. All engineers are encouraged to attend dashboard review so that they can see the types of questions that are asked, dashboards used by others, and generally learn best practices that they can use with their own service-specific metrics. It is by having many avenues of education and communication that we are able to make our incident response process a success. And we enjoy conferences like these because they allow us to take back our learnings and make our own systems better. Thank you for listening. We hope that this little bit of insight into our postmortem process was interesting and will give you something to think about as you evaluate your incident response processes. If you want to learn more about the opportunities at Cash App, please visit our career page at cash.app/careers. Thank you.